Hello, and welcome to this video on the 6 trig functions. I'm going to give a definition of the 6 trig functions, as well as an explanation of where they come from. I'll do 2 examples, okay? The second example is a little harder because it involves rationalizing a denominator. That's a skill you should have if you got here. Okay, that's a quick broad strokes overview, okay? And here, there's some time signatures about where to fast forward to if you'd like to. Depending on what you'd like to see, feel free to watch the whole video if you'd like. And what will this video deal with? It will deal with the basic question posed to people when dealing with the 6 trig functions, and that is determining the value of the 6 trig functions for an angle in standard position intersecting a given point. Okay? So let's move forward to the definition. Okay? The 6 trig functions are defined as follows. Given an angle we'll call theta in standard position, whose terminal side intersects a given point, x comma y, the 6 basic trig functions are defined as follows. Their names are cosine, sine, and tangent, secant, cosecant, and cotangent. Okay? And they are gotten by doing the following, just doing a fraction, if you will, a ratio or a division, however you want to call it. The cosine of theta is x divided by r, sine of theta is y divided by r, tangent of theta is y divided by x. And then notice here, the 3 on the right are in fact just the reciprocals of the one on the left. Okay? So you see here that we have this nature of reciprocals. Okay? So, and again, secant of theta is r over x, cosecant of theta is r over y, cotangent of theta is x over y. Okay? You need to be able to recognize the reciprocity, if you will, of these. Tangent of theta and cotangent of theta sound like a pair because they sound alike. And then how I remember it is that the cosine pairs with cosecant on an angle, and sine pairs with secant on an angle. If you notice, it's not a C word paired with a C word. It's not an S word paired with an S word. Okay? That's kind of how I remember it. Okay? A couple things for remembering this too. I kind of remember tangent as sort of the word tyx, T-Y-X. And cosine and sine, I remember that C and S are alphabetized, and so are X and Y. So it would make sense to pair the C with the X and the S with the Y. So you're going to have to spend some time memorizing that chart. And obviously we say there's a given point called xy, x comma y, and a lot of x and y is going on in this chart, but then where's r? Well, r comes from this formula here that I've saved till the end, which is r equals the square root of x squared plus y squared. Okay, so where do these definitions come from? Okay, give a little better explanation of these formulas, just where they are. So where does this come from? It comes from geometry and an idea that you probably have dealt with if you're dealing with right triangles in geometry. You may have heard the idea of some hold horse caught another horse taking oats away, or you may have heard of something called Sohcahtoa. You have to have a background in that because what we're doing is we're transferring that geometry into the xy plane, which is an algebra idea, and coming up with now what's called trig. So what you're getting is a geometry idea crossed over with an algebra idea that gives you this idea of trigonometry. Okay? So you've probably seen the Sohcahtoa laws as sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, the tangent of theta is opposite over adjacent. Again, in dealing with sides of a right triangle. Okay? So let's try and talk about how to transfer them over into these trigonometric ideas. Okay, so we said we're going to have this given point xy that I've just drawn in the plane here. And we've talked about the fact that we're going to have this terminal side of an angle called theta that is going to go through that point. So we've got this angle now sketched in standard position. But if you notice here, I could probably form this right triangle here associated with that angle in standard position, okay? Maybe I'll even change the colors here so you could sort of get a little better sense that there's a triangle there, okay? And it has this blue terminal side going through it. Well, the blue side is where we're forming this angle, okay, with the positive x-axis. Okay, so what is it we have here? If you notice, if this point is x comma y, then the base of the triangle, in fact, could be thought of as x because it's x to go over, and the height of the triangle could in fact be thought of as y because you're going to go over x and up y, okay? And then that just lends itself to this idea of r, okay? Well, where do we get r? Well, if you think about it, I could in fact place this whole phenomenon in a circle where the circle's centered at 0, 0, and in fact the point xy is on the circle, and then r is simply the radius of the circle. Now, how are these things related? Well, it should be pretty obvious here that r is the hypotenuse of the triangle, this right triangle here. R is across from the 90 degrees. And then, in fact, we would see in relation to theta, if we went across from it and saw y, y would be the opposite side. And if you notice here that this x side runs into theta, so it in fact is the adjacent side. So now what we've done is we've just drawn a comparison between x, y, and r, being known as the adjacent, the opposite, and the hypotenuse respectively. Okay, so now if we take a look at these laws that I've organized here in the margin, the cosine of theta was adjacent over hypotenuse, also known as caught another horse, or the ka part of SOHCAHTOA. The adjacent we see is in fact x, and the hypotenuse is in fact r. If you notice from the definition table, cosine theta equals x over r. And you see that we have the sine of theta is some old horse, right? Also known as the SO part of SOHCAHTOA, right? We have its opposite over hypotenuse, and we see that the opposite is in fact equal to y, and the hypotenuse in fact is equal to r in this drawing. And it's not a shock that that was the original definition I talked about when I defined it on the previous slide. Okay? And then the tangent of theta, which is from taking oats away, or the TOA part of SOHCAHTOA, is opposite over adjacent. So we have that the opposite, again, is equal to y, and the adjacent is equal to x. So the tangent of theta is equal to y over x. And if you notice, that's how I defined it, was y over x. So it's not me that has defined it. It's, just historically defined that way. Well, that talks about where the SOHCAHTOA is involved, and it's sine, cosine, tangent, and then it's not too much of a stretch for you guys to see that if you just took those three laws and made reciprocals, you would get related laws that have different names, okay? So that is where this idea of SOHCAHTOA, where some old horse caught another was taking oats away, which is right triangle phenomenon work in geometry. Then when we put it in the xy plane, you get trigonometry, and the laws are defined this way. Okay, so now let's go to an example. For the given ordered pair, we want to do the following three things. Sketch the angle in standard position whose terminal side intersects the given point. Sketch the associated right triangle, and determine the values of the 6 trigonometric functions of theta. Okay, so I'm going to have to sketch -3, 4, which is up here. And then the angle in standard position has a positive x-axis initial side, and it's a ray that is going to go through -3, 4, is the terminal side. Then you have to realize that the angle is in fact here. This is what theta is. A lot of people want to say it's this angle. It's not, because it seems like that's the part that's hugging the axis. We've in fact created an obtuse angle here because we've rotated it from the initial side of positive x into the second quadrant. Okay? So it's in fact going to be drawn as such. Okay, now I'm going to make a little chart that says x, y, and r. X is given, it's -3. Y is given, it's 4. And r is going to be computed by the formula r equals the square root of x squared plus y squared, which is just from the Pythagorean theorem using x and y as sides of the triangle. Okay, so we get r equals -3 squared plus 4 squared, all square rooted. So r is going to give us the square root of 9 plus 16. So r equals square root of 25, and r equals 5. I'm going to move this up a little bit here. Okay? And now that's going to allow me to associate this triangle that I'll make in the drawing. Okay? Where we have a -3, 4, okay, and this is a 5 for the radius, okay. This point up here is -3, 4, okay, and you have to realize here this is sort of vectorized in the idea that we've gone -3 to the left, and you do need to use that sign when doing the trig laws. Okay, so it's just basically recopying the laws from here and making sure I rationalize any denominators and simplify them if I need to. So we've got that the cosine of theta is equal to x over r, which is -3 over 5, and that's in its simplest form. The sine of theta is equal to y over r, which is 4 over 5, and that's in its simplest form. And then we've got the tangent of theta is equal to y over x, which is equal to 4 over -3, and that's in its simplest form. You can say -4/3 or the opposite of 4/3 or 4 over -3. Now we're going to do the reciprocals, and the reciprocal of cosine is in fact secant of theta, which is r over x, which is 5 over -3 or -5/3. And the reciprocal of sine is cosecant of theta, which is r over y, which is 5 over 4, and that is in fact in simplest form. Then we get the cotangent of theta, which is equal to x over y, which gives us -3 over 4, and that's in simplest form as well. Okay? So that's a basic example. Okay? And again, what we have here is an angle sketched in standard position, okay, which intersects a given point. We have an associated triangle with it. It's a right triangle, so we were able to find r using this formula over here in the margin. Okay? And then the basic definitions I did the 6 trig functions from are the ones that we have here from the previous slide that I spoke of, or you've seen them in class and are familiar with them already. Okay? So now I'm going to do another example. This one's going to be a little bit harder. Okay? So again, it says to sketch the for the given ordered pair, sketch the angle in standard position whose terminal side intersects a given point. Sketch the associated right triangle, and then determine the value of the 6 trigonometric functions of theta. Okay, so I'm going to sketch 2, 4 here. Okay, and then I'm going to sketch the angle whose terminal side is intersecting that. Okay, so if you notice, I just drew a ray, a little too long, a little off the chart. Okay, so the angle involved, in fact, is right here because it's theta. It's extending from the initial side of the positive x-axis. Okay, and then I could draw in my sides for the right triangle. Excuse me, I don't want to draw rays there. So we're going to get a right triangle here whose sides are 2 and 4 to start, right? So I'll make a little chart that says x equals 2, y equals 4, and then we'll need to compute r, okay? So r will be equal to 2 squared plus 4 squared, all square rooted, which is 4 plus 16, all square rooted, which is the square root of 20, which can be simplified by calling it r equals 2 root 5, okay? So we've got that r equals 2 root 5. I'm going to just move this out of the way because this is going to involve some writing. Let me shrink it down here. Okay? Now, if you notice, I'm not dealing with any negatives because I'm in the first quadrant, but there is going to be a small difficulty here in dealing with this 2 root 5, and it involves rationalizing a denominator. This is a skill that you should have. If you don't, you better go try and master it. Okay, so let's see what we have here. We've got that the cosine of theta is equal to x over r, which is equal to 2 over 2 root 5. Well, I can simplify the fraction part and get 1 over root 5. But then I need to realize I can't have a radical in the denominator. So I'm going to multiply by root 5 over root 5, which really is the number 1 if you think about it. So I'm not really changing anything. So that is going to give me root 5 over 5. And now that's in simplest form. You have to realize that this is not in simplest form because of this radical in the denominator. So you have to do this rationalization trick. Okay? So when I look at the sine of theta, I know that that's y over r, which is going to be 4 over 2 root 5. I can simplify 4 over 2, okay, and that's 2 over root 5. But again, I have to rationalize the denominator by multiplying by root 5 over root 5, which in fact is going to give me 2 root 5 over 5, which can not be simplified any further. Now, the good news of dealing with tangent of theta is that it's just y over x, and neither of those have a radical in them, so I've got 4 over 2, and that is equal to 2 when I put it in its simplest form. Okay? So let me just make a little space here, a little bit. Okay? And now I'm going to be able to do the reciprocals of cosine, sine, and theta, which respectively are secant, cosecant, and cotangent. So the secant of theta is equal to r over x, which kind of is nice here because that's allowing me to have the radical on top. So I've got 2 root 5 over x, which is 2, which can be simplified into just root 5. And then I've got the cosecant, excuse me, just try to keep the colors the same modality here. The cosecant of theta, which is the reciprocal of sine, so it's r over y, which in fact is equal to 2 root 5 over 4. Another good thing to have your chart for reference because you're going to have to look at it a bunch of times, which can be simplified to 1/2 root 5, also known as root 5 halves. Then the cosecant is followed by the reciprocal of tangent, which in fact is cotangent of theta, which is the reciprocal of y over x, which in fact is x over y, which is just out of the chart as 2/4, which can be simplified to 1/2. Okay? So, I have my answers here for my 6 trig functions, and they are in fact gotten by just the way the rules were defined a few slides back if you watched it. These 6 values are given by these ratios, okay, involving the given point, x, y, and r, excuse me, x and y, and then using x and y to find r. Okay? So, I hope you enjoyed this video. Feel free to practice, feel free to share, and I hope it was informative.